A toy-powered car of mass 20 kilograms on a horizontal rough table is being used to pull a 6 kilogram block hanging freely vertically upwards. The rope passes over a light smooth pulley at one end of the table. The resistance to the motion of the car is 15 newtons. Draw diagrams to show the forces on the car and the block. Calculate the driving force required for the car to give an upward acceleration of 0.2 meters per second squared and the tension in the rope. Assuming the block starts from rest, how long will it take the block to reach 0.4 meters per second, and how far has it been raised in this time? Okay, so drawing the force diagrams. So first we'll consider the block. So the block, we're going to have the weight of the block acting downwards, which is going to be 6g newtons, and the tension acting upwards on the rope. There will be an acceleration of 0.2 meters per second squared. For the car, there will be the tension in the rope, which will be the same as this tension here. There will be the resistance force, because it's moving along a rough table. We have a 20g newtons acting downwards, the reaction to that, and then we have a driving force. We're going to ignore any air resistance. The acceleration will be 0.2 meters per second squared. B, resolving for the block, we're just going to resolve vertically here. So that's going to be T minus 6g is going to be equal to 6a. That's using Newton's second law. So that's going to give T minus 6g, and the acceleration we're told was 0.2. So we're going to have to do 6 times 0.2 plus 6 times 9.8. G we take to be 9.8. We're going to get 60 newtons. For the car, resolving horizontally, we're going to have D minus the tension minus the frictional force is going to be equal to 20 times A, the mass of the car, times the acceleration. So it's D minus 60, and in the question we're told the frictional force is 15, is equal to 20 times 0.2. That's going to give D is going to be 20 times 0.2 plus 60 plus 15, which gives me 79 newtons. We require that V is equal to 0.4 meters per second as a speed. Note that the acceleration is 0.2 meters per second, and that U is 0 meters per second because it starts from rest. Using V is equal to U plus AT. V, it's a good idea to do this, A and U. So we're going to have 0.4 is going to be equal to 0 plus 0.2 times T. That's going to give T equal to 2 seconds. So it takes 2 seconds to reach a speed of 0.4 meters per second. The distance travelled in the first 2 seconds from rest we can get by doing S is equal to UT plus a half AT squared. Remember the acceleration is constant, so this is T, and we've got all the other variables up here. So we're going to have S is equal to the initial velocity, which is 0, times the time, which is 2. It's going to be 0, plus a half times the acceleration, which is 0.2 times 2 squared. That's going to give that the S will be 0.4 meters. So the distance travelled in 0 is going to be 0.4 meters. Okay, so there's been a video showing you a connected body, one moving horizontally, one moving vertically, and using also the Suvat equations. I hope you've understand, and I thank you very much for watching.